Okay, so a couple of things. You do not need to put your name in any of those spots. We're gonna call those rider A, B, C, and D. Doesn't have to be you. And what I want you to do next, I think, if I remember correctly, there are two that you have to start with. Yep, there's two that you have to start with. You have to grab first. Try to identify the two riders that you have to put down first. Basically, that have enough information to make a line. Okay, I'm gonna walk around. If you think you know which two that you need to start with, raise your hand. Show me which two. I'm gonna tell you whether or not you're correct. Yep, got it. At the top. Yep. You guys can speak words. You want to? Not yet. Yep, perfect. Okay, so then graph those two. Once you figure out the two you can graph. Yep.
Oh no, oh yeah, so she's.
Yep. Yep, that's one of them. Yep. What's the other one you have in the big section? Yep. Okay, so start by graphing those two first. Perfect. Nope. So 4 seconds, so that's a coordinate. That's cool. Another coordinate, and then you can make a line. Start graphing those two.
So you see.
Okay, now we need to talk about Leslie real quick. Does Leslie get a head start? No. What does it say for Leslie? 2 meters per every second. 2 meters per second, and then what? 2 seconds after. Okay, so that means you have to go over here 2 seconds after. So she started 2 seconds in. And then 2 meters every second. Okay, now what I'd like you to do is after you graph this and get your line, extend your line down here so you can figure out what her y-intercept was. Oh man, that was not my best work at the top. The ruler moved. Just don't look at the top of my line. Just don't do it. No, you don't. Yeah, see, look. So bad. Okay, after you get Leslie, then grab Elizabeth. Hers is kind of flat. Don't forget to put Leslie's equation and Elizabeth's equation. Of course. Just a second. Because I feel like I had to do everything in erasable except. I'll just leave it right here so we can share it. Don't forget to put Elizabeth's equation and Leslie's equation. I think rider B is probably the next easiest one to graph. If you're ready to move on, I think you could also do B, but I think rider B is the easiest one to do next. Yes, yes. So they're trying to be like, you need to
start.
That's to make you figure it
Because
out.
she had, because her head start was back. But the points that were given to us were first points of that. Yeah. No, you start because you first point and then you go to four.
Yeah, I didn't want to do
and
that.
go up to wherever.
Yeah.
Line is. And then you make your line there.
Oh, no, 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 no.
Okay, what do you think we can do after B? What's the next easiest one? C? Okay. You ride half as fast as Leslie, but get a 4-meter head start. Okay, so 4-meter head start. Leslie went 2/1, so this is 1/1. Yep, and what's half of 2? 1x. Mhm. Huh, it looks like we're either gonna end up with 6 or 7 lines on here. 6 or 7. Depending on if you graph the finish line. So you'll have 6 or 7. 6 or. Does anybody know what the finish line is? 25. Okay. That's easy. Oh, I have to do 2 more actually. I haven't done D or A. I'm slacking. I haven't done line 6 or 7 yet. I did line 5. Now we'll do 6, then we'll do 7. What? Okay, what's next? C? No. D? You get a 1 meter head start. Okay. Catch up to Elizabeth after 4 seconds. Okay, so that means that it's going to connect to Elizabeth's dot right here. And what is that slope? Up 10 over 4, so up 5 over 2. Does that look right? I think that this person should be purple. Plus 1. What's wrong? Which one was this, D?
Wait, how did you, where do you start?
For D, it says you get a 1 meter head start. So you start at 1. And then you catch up with Elizabeth after 4 seconds. So you're going to match up with her 4-second dot.
I just like draw like right here.
Yep. And then what I did was I counted so if you watch my pen, I went here and I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. So I knew it was up 10 over 4. So I knew I could go up 5 over 2. Just to make my line more accurate. Okay, I have one more, correct? I'll give it a second because I don't want to go too fast here. So you have 6, not 7? I don't have A either. Okay, so I'm going to start A. It says you ride your tricycle 3 meters every 2 seconds and pass rider B 10 seconds into the race. So what I have to do is I have to locate rider B. For me is green. And at 10 seconds, it's right here. Okay, so I found 10 seconds in for rider B. Then what I'm going to do is count up 3 over 2, up 3 over 2, up 3 over 2, and then I'm going to backtrack it down. Do you see what I'm saying? Oh no, the ruler moved again. It's gonna be a really fat line. It's fine. Let me see if I'm gonna give you 60 seconds here and then I will take questions. You did it? How many lines do you have? Maybe not including the finish line and including the finish line. And then with the finish line? You just fell into my trap. I have to show you guys something. So we made an exit ticket for Math 3. You can't tell them. But you have to look at the problem. That's good. That's good. That's good. I can't wait. It's not till Monday though. I have to like hold on to my humor until then. It gives me something to look forward to. Okay. So, does anyone need any questions answered about the graph? Where I got any of the points? Well, you can see mine. Yes, honey. What? Oh, this? That's a 5. It was just a loopy 5. I didn't really do it any better the second time. Oh no, it's just my font. Did I graph it right though? Yeah, okay. Anything else? Other than my bad handwriting? I mean, why don't you just draw a second one at 25 and then write like finish in it like it's spray painted on the cement. It's my idea to fix that situation. Ding. Yeah. Okay, so now scoot your graph off to the side and grab your notebook. We have questions to answer about our graph. Oh, wait, hold on. We have to do other stuff. So check your rider A is y equals 3 over 2x. And you can put plus 0 if you want. Rider B is y equals 1 over 2x plus 10. Rider C is y equals x plus 4. And you might have 1x plus 4 here. That's fine. Rider D is y equals 5 over 2x plus 1. Leslie is y equals 2x minus 4. Make sure you have the minus 4 there because her y-intercept is -4. And then Elizabeth is y equals 1 over 4x plus 10. Are we good on that? Hopefully you guys were doing that as you went. Okay. Back to this. Okay, first question, A. Who won and who came in last? Yep, who crossed the finish line first? D. Who was last? Elizabeth. Okay, question B. Who was in first place for a little bit? Question B. Who was in first place for a little bit? It was B, rider B. Because in the first, let's call it 4.5 seconds, the green line is on top. So rider B was in first place for about the first 4.5 seconds. Okay, C. How long did it take rider D to win? Question C. How long did it take rider D to win? Okay, all of the things you said are good. Over here, what we're going to do is we're going to say 25 equals 5 over 2x plus 1. So we're saying, where is rider D 25 seconds? Your estimate from the graph being about 9.5 is pretty good. Okay, what do I do with the fraction? Yep, times by 2 on both sides. That gets rid of the 2 in the denominator. Look how close you guys were. Okay, next question, D. What are rider D and Elizabeth's unit rate? Okay, so what is unit rate? Let me scroll back in the packet and read it to you. Unit rate is a slope with a denominator of 1 with units. So what we do is we just take the slope and actually divide it and make a decimal. What was the slope for rider D? Yep. Okay, so 5 over 2. What is 5 divided by 2? So 2.5. And what are the units? Meters per second. Great. Okay, what was Elizabeth's slope? courtier. Mrs. Talbot speed right there. What is 1 divided by 4? Okay. Question E. At one point in the race, 4 different participants were the same distance from the starting line. Who were they and when did this happen? Yeah, okay, so Leslie, rider A, rider C, and Elizabeth? And what I'm looking at is this coordinate right here where all 4 of these lines cross in the same spot. What is this coordinate? Nope, not today. I would have been so excited if that was the case, but what is it? 8, 12. Yeah. Okay, last question for this graph. What would the graph look like if one of the riders fell off their tricycle? Flat, yeah. Like that. That would gone flat. Okay, we have one more problem, and then I'm gonna do a large amount of stamping while you're working on your homework. The homework is quick, by the way, which is great. You already, yeah, it's super easy. It's physics. Ooh, just bumped it. Mhm. Okay, I will. I don't really need to go in order anymore because I know everybody's names now, which is so helpful. I have a question though, while you're doing stuff. Did I stamp everybody's slope puzzle already? Okay. So this thing is the slope puzzle? I did not, okay. Did I stamp any slope puzzles? Okay. Okay, number 70, last question of the day. What does it mean to be a solution of an equation like a line? And there's 2 things. The point is on the line. That's the way to tell graphically if it's a solution. Or the point works in the equation. You know how like all year I've been making you do the check for all of your equation solving. So this is basically the check. Okay, so first, let's just look common sense wise. So this is Leslie, by the way. So go 1, 2, 3, 4. So there is her y-intercept of -4. And then she did 2 meters every second. Okay, now let's just use common sense. Is 6, 8 on the line? If I kept the line going, would it be on the line? Yes. Okay, so yes, it's on the line. Okay, but what I'm going to do next is I'm going to show that it's on the line algebraically. And I'm going to label this as an XY coordinate. And I'm going to put the 8 in the Y spot. And 6 in the X spot. So I have a method for my visual people and I have a method for my algebra people. Okay, now what do you think about 8, 6? Is 8, 6 going to be on the line? No. Let's show it algebraically. Okay, the homework is graphing stories and situations worksheet. This is a matching worksheet. It's very fast. Describe these velocity graphs worksheet and Sarah's graph. It looks like a lot, but they're actually really easy. Sarah's graph is this one. So work on these, please, while I stamp. I think I need to stamp all of this. Does that look correct to you?